internal combustion engines, whether they use gasoline or diesel fuel, require two very important criteria in order to operate effectively and efficiently. They require a high level of protection and large quantities of clean air. All these engines have one common denominator required to perform as designed and run countless hours year in and year out. That common component is an air filter. The first task of a diesel engine's air filtration system is to stop dirt from entering the engine. Most air filtration systems on today's diesels use a dry-type air filter similar to the one shown here. These filters typically use a cellulose filtering media. The media is basically a specially formulated paper designed to trap dirt particles within a complex mat of fibers. Thus, a large surface area of filter media is needed because internal combustion engines ingest large quantities of air for every tiny drop of fuel consumed. Diesel engines, for example, consume over 10,000 gallons of air for every gallon of fuel they burn. Tests have shown that in the course of a year, the typical over-the-road tractor is exposed to 110 to 115 pounds of airborne dirt, while vehicles used in off-road applications are exposed to 1.5 to 2.5 tons of airborne dirt and debris. It's hard to realize that while these off-road earth movers haul hundreds of tons of material per payload, it takes just a few ounces of dirt to lead to the complete and early failure of an engine. And the only way that dirt can enter an engine is through the air filter. In addition, dirty air filters will cause less than optimum fuel-to-air ratios to occur, with the result being excessively dirty exhaust emissions polluting the air and decreasing fuel efficiency. Maintenance-minded equipment owners generally agree that changing air filters on a regular basis is the best way to assure optimum protection for engines. Waiting until the restriction indicator says that the filter needs replacement doesn't seem to be the most conscientious practice of preventative maintenance. A leading manufacturer of air filters says replacing air filters before the end of their useful service life is not a good maintenance policy. As unreasonable as it sounds at first, replacing filters too frequently actually can cause the engine to ingest more dust and dirt during its life than if the filtration system received less attention. As tests have shown, a brand new filter will let more dirt through to the engine than a filter that has been through 20% or more of its useful life. Almost all of the dirt that gets through an air filter passes through during the early stages of the filter's life. It is only after the first 5 to 15% of the useful life of a high-quality air filter does it become 100% efficient. It is important to realize that all filters begin life less than 100% efficient. Not until a porous cake of soot builds up on the filter media does the filter reach maximum efficiency. This caking phenomenon actually transforms the undesirable level of filtration into an acceptable level in a short period of time. Replacing an air filter too early is not smart. Replacing them too late is unacceptable. And replacing them too often is not cost-effective. All these procedures cost you money. So what's a conscientious operator to do? To protect his equipment, save money, and help reduce emissions and meet recycling mandates? The answer is, have your air filters cleaned by the sonic dry clean process at a fraction of the cost of a new filter. This practice will provide you with greater engine protection while reducing large masses of non-biodegradable waste from entering our landfills. The sonic dry clean process has over 20 worldwide patents. It is a machine constructed of materials made to last. It has stainless steel air cylinders, cast-hardened steel wear surfaces, Teflon and phos-bronze bushings. It has solid-state electronics with a sequence programmable computer, and it's totally automatic. The machine can clean a heavy-duty air filter in less than 5 minutes. It will not only clean a dirty filter in less than 5 minutes, but a sonically clean filter will have a better operating efficiency than a brand new filter. The sonic dry clean process uses no chemicals, solvents, or fluids of any kind. It uses no toxic or hazardous materials. Instead, it uses a computerized sequence of high-pressure air, vacuum, and vibration to extract the dirt from the filter while leaving the pre-coat behind. This feature of leaving the pre-coat in the filter allows the sonic process to attain a higher operating efficiency than a brand new filter. A sonically clean filter has a starting efficiency of 99.6% compared to some new filters that are 97 to 98.5% efficient. The difference between these few percentage points may not sound that significant until you realize that a new filter will pass about 8 to 10 grams, or about 1/3 of an ounce or more of dirt into an engine than a clean filter. And for this reason, your engine receives better protection, better fuel efficiency, and better operating performance when cleaned filters are used as replacements instead of new filters. The entire sonic process consists of several integrated steps in order to produce the desired result in the finished product. Prior to cleaning a filter, the first step in the process is to take a manometer reading. This measures the amount of airflow or restriction across the filter in inches of water. Because of the versatility of the sonic dry clean system, it is the only system that the operator can select the proper sequence to ensure that the dirt is always extracted from the filter in the same direction that it entered. Dirt is never forced through the filter. As you can see, once the filter is placed inside the chamber, the machine automatically adjusts to the correct height and diameter of the filter regardless of the filter's dimensions. After the filter is firmly secured and held in place, a rapid and positive vibration cycle begins to loosen any impacted dirt and debris that may be lodged between the filter pleats. Next, a sonic blast of air expels from the inner nozzles, dislodging a vast portion of the dirt that may be embedded in the filter. Then the strategically placed and engineered nozzles move into place to scrape the remaining dirt from the filter surface area, while the inside nozzle sonically flutters the pleats to ensure complete detachment of all foreign material. Simultaneously, a high vacuum is both extracting dust from the main chamber as well as supplying a vacuum at the surface area, evacuating the dirt as it is being dislodged by the air nozzles. High-pressure air is never blown directly at the surface of the filter, but rather at specifically engineered angles, peeling the dirt away from the filter's surface as the filter is rotated to ensure complete coverage of the surface area. The entire cleaning cycle takes less than 5 minutes. During the cleaning cycle, the operator is left free to perform other job tasks. After the filter is cleaned, another manometer test is performed. This reading shows the drop in airflow across the filter in inches of water. After finishing the filter, the operator then takes the filter to the light source to inspect the filter element for holes and/or defects in the filter media, which may cause severe problems if put back into operation. What does all this mean? By reusing instead of throwing away air filters, a company will save on new air filter costs. Provide superior protection for your engines by reducing engine wear. Reduce the amount of unhealthy emissions their equipment generates. Reduce the amount of non-biodegradable waste from going into our landfills. The bottom line is cost savings plus aggressively protecting your engines and the environment. Sonic Dry Clean.